Now, we are about to begin with levers. We have done what is a machine, what is load, what is effort, what is mechanical advantage, what is velocity ratio, and what is efficiency and relationship between these three. So now we are going to take up levers. Now, what are levers? A lever is a simple machine consisting of a beam or a rigid rod. In few examples, in the earlier slides, I had told you that this is a lever. So a lever is a simple machine consisting of a beam or a rigid rod pivoted at a fixed hinge or fulcrum. A lever is a rigid body capable of rotating on a point on itself. On the basis of the locations of fulcrum, load, and effort, the levers are divided into three types. Now, what are these three types? We are going to study further. So, students, the first class lever will be when the effort and load are on the extreme ends and the fulcrum lies between effort and load. Okay? So here you can see effort is a green arrow, load is a red arrow, and the pivot is showing the fulcrum. So the first class lever will be when the fulcrum lies between effort and load. Okay? The second class lever will be when load lies between fulcrum and effort. Okay, when load is in between fulcrum and effort, then it is a second class lever. And when effort is between the fulcrum and load, then it is a third class lever. You have to remember this. First class lever, fulcrum is in between. Second class lever, load is in between. And third class lever, effort is in between. Now, as I mentioned in my earlier slides, in the earlier class, that principle of lever or principle of machines is the same as principle of moments. So, principle of lever, in all the cases of levers, the principle of lever will be the same as principle of moments. That is, moment of load about fulcrum to moment of effort to the fulcrum. Okay, so load into load arm is equal to effort into effort arm. So here, if I say L is the load and FB is the distance of the load arm. What is the load arm? From the fulcrum to the load. Okay, and what is the effort arm? From the fulcrum to the effort. Every time. So, load upon effort is equal to AF upon BF. I have not shown here AF and BF, but I'll show you in the next slides. So, L upon E is equal to AF upon BF. So, mechanical advantage will be load upon effort. And that will come as effort arm. If I write effort arm in place of AF and if I write load arm in place of FB, you will understand that L upon E comes to effort arm upon load arm. So you have to remember this. This formula will be used up in lot many numericals. So you have to use this. And you have to learn this by heart. Mechanical advantage is effort arm upon load arm. Okay. So we move further. Now students, I have made up this chart so that it becomes easy for you people to study. Otherwise, you have to hunt these things in the book. I have made this chart for you people. Now for class 1 lever, where the fulcrum is in between the effort and load. In that case, if EA is greater than LA, EA is effort arm is greater than load arm. In that case, mechanical advantage will be less than 1. If effort arm is less than load arm, and mechanical advantage is effort arm upon load arm, we have just now studied. So if numerator is less than the denominator, obviously mechanical advantage will be less than 1. In that case, it will be a speed multiplier. That means the lever will be a speed multiplier like scissors. Now, if you take the example of scissor, effort arm, that means from where you hold the scissors, that arm is small as compared to the length which is cutting. So, the load arm is bigger and effort arm is smaller, and therefore this class of lever, in the case when effort arm is small and load arm is big, is used up as speed multipliers. Okay. Now in the same class, if effort arm is greater than load arm, that means if mechanical advantage is more than 1, it is known as force multiplier. I have told you what is a force multiplier. Now, the last case, if the effort arm is equal to load arm, that means mechanical advantage is equal to 1. That means it is used up in changing the direction. That is seesaw. Okay. Now we come to class 2 levers in which load is in between the fulcrum and effort. In that case, what will happen? Effort arm is greater than load arm. Obviously, now load is in between. So, load is closer to the fulcrum and effort is far from the fulcrum. So, obviously, the effort arm is more than the load arm. So, in that case, mechanical advantage will always be greater than 1 and machine will act as a force multiplier. So, case 2, all the machines will be force multiplier. And case 3, effort arm will be smaller because effort is in between the fulcrum and the load. So effort arm is small and load arm is big. The numerator is small and denominator is big. So mechanical advantage is less than 1. In this manner, machine will act as a speed multiplier. So any machine which happens to fall in class 3 levers will be a speed multiplier. Okay. I hope the things will be clear. When you draw this chart and you understand and you go through the book once, if you read the book once, the things will be clear to you. If you still have problems, you may ask me here in the comments below. So we move further. Now, in this slide, I have taken a few examples of first order, second order, and third order levers. That means first class lever, second class lever, and third class lever. So, first class, where fulcrum is in between, you can see hammer. That you can see where is the effort, where is the load, and where is the fulcrum. You can see the pliers, where is the fulcrum, where is the load, and where is the effort. Then you can see the wheelbarrow. Now you can see where is the fulcrum of the wheelbarrow. Can you see? In the wheel. Where is the load? In between. And where is the effort? In the corner. Okay. The same way nutcracker. See where is the fulcrum, where is the load, and where is the effort. Third order. These this thing we will take up later, where the human parts as a machine. But you can see the sugar tongs. Where is the fulcrum? In the end. Where is the effort? In between. When you are holding the sugar tongs, you have to apply the effort in between. And load, that means when you are picking it up, the load is in the corner. Okay. So these were the few examples of first class lever, second class lever, and third class lever. And I hope now you must be clear with the levers. Okay. So we move further. So, as I said, we will study the class of levers as machines in our body. So, the first is class 1 lever, and where is it? When we are nodding our head. When we are moving it up and down. So, how is it a lever in that case? So, when you are nodding, you can see that where is the fulcrum? As shown in the figure, the fulcrum is from where the head is connected. So that is the fulcrum. And when you are nodding, then you can see where is the effort. From where are you applying the effort? From the neck, from the back side of the neck. So that is the effort. And what is the load? You can see. Okay. So this nodding of head will come as class 1 lever. Okay. Fulcrum is in between, effort in one corner and load in one corner. Okay. Now, the second class lever is when raising the weight of the body on toe. When you are taking up the whole weight of the body on your toe. In that case, what is happening? The fulcrum is on the toe. The effort is in the leg. You can see as shown in the diagram. And where is the load? You have seen. Okay. So this will come under class 2 lever. And the last one, class 3 levers in the movement of raising a load by forearm. So you have to keep something in your hand and you have to hold it like that. So in that case, lever class 3 lever is being used in that case in raising the load by the forearm. So you can see here where is the fulcrum at the joint. And where is the effort in the upper part of the hand and where is the load in your palm. Okay. So these are the 3 class of levers in a human body which we have done. Now numericals I will take up later in the next slides. So I think I should end up over here. If you have any doubts, any problem, please ask me in the comments below. And try to understand the things well. Physics is very easy. After going through the slides, please read the book once and I am sure that things will be 100% clear to you and you will love physics. Thank you so much. We'll meet later. Thank you.